Hey guys, tonight we're going to go over that second review sheet you had. So on your review sheet, it should say at the top, Math 12 Honors, and it should say Review 4.1 to 4.3 Mixed. Now, since we're not in the honors class, we're going to skip some of these questions that I told you you won't need to know. All right, so let's start with question number one. So question number one, I don't have the ditto, I apologize. So I'm just going to have to write it out. So they give us a problem. 2x squared minus x plus 3 equals 0. And they want us to solve by completing the square. All right, first, I don't like the 2 in front. So I'm going to divide every term by 2. So I'm going to divide everything by 2. We're going to get x squared minus 1 half x plus 3 halves equals 0. Now, completing the square, we move over the regular number, so I get x squared minus a half x equals negative 3 halves. I take half this middle term here, the 1 half. So now half of a half, you double the bottom, so it's 1/4. So it's x minus 1/4. Now the thing is this though, if I had a 1/4 down here, when I FOILed it out or squared it, it would be plus 1 over 16. And if I put plus 1 over 16 over here, you better put plus 1 over 16 on this side. Punch this in, brains or calculators, I don't care how you do it. Make it a fraction again, negative 23 over 16. To get rid of the square, we take the square root. So it's going to be x minus 1/4 equals positive negative radical negative 23 over 16. X minus 1/4 equals positive negative. Now, the 16 can come out. The negative can come out. The 23 I can't break down, so it's going to be I over 4 rad 23 upstairs. Last step, x equals 1/4 plus minus I rad 23 over 4. And that's a pretty complicated, that's a good level, complete the square. It's on the higher end. That's a good question. So that's our answer. Now, this is question 2. Do the same problem, quad formula. All right, so we'll do the same thing using the quad formula. X equals negative b plus minus radical b squared minus 4ac all over 2a. This is a formula you must have memorized. You're going to use it from now until forever in math. Just get used to it and memorize it. Now, looking over here, my a, b's, and c's. My a from the original problem was 2. B is negative 1. C is positive 3. These are the values I'm going to plug in the problem. So I'm going to plug in. So it's going to be x equals 1 plus minus radical 1 minus 4 times 2 times 3 all over 4. You're going to clean this mess up on the inside. Once again, brains or calculators. 8 3 is 24. 1 minus is negative 23. So you can start seeing where it's going. 1 plus minus, the negative comes out. I rad 23 over 4. Same answer. This is actually split up to a, b, I form. This is just all together. So it didn't say it must be an a plus b, I form. So it's all good. Let's try the next one. So question 3. They give us some roots. And it's 1, a 1, and a 1 plus minus I rad 2. Now, we just did one in class, so y equals, you're going to put these guys back in, so it'll be x minus 1, x minus 1. You could have written x minus 1 squared. That's totally legit. But now I'm going to need to put this guy back together. Remember we talked about imaginaries and radicals are conjugate pairs. That's why it's the plus minus. And from this one, we're going to do our sum and product of the roots. Sum and product. So now the sum. 1 and 1 is 2. I's cancel. The sum is 2. The product, you're going to multiply this out. Do what you can do. 1 times 1 is 1. This one's going to be a little tricky. So 1 minus rad 2 is 2. I times I is I squared. I squared. So I squared is negative 1 times 2 is times negative 2, excuse me, is positive. So this is, product is a 3. And if you recall, we used to do negative b over a, c over a. In this problem, a is a 1, so it's x squared, opposite on the b, minus 2x, keep the c, plus 3. Now, this is a perfectly good answer. It didn't say we had to write in polynomial form, or we had to write it all out. It just says write least degree. Let's try it again. Question 4. Y is greater than or equal to 2x squared plus 5x plus 3. Oops, lost the x. This goes in the calculator, so we're going to punch this in the calculator. All right. So now with the inequality, we're going to do some shading. Okay. I apologize. On your thing, you have an axis, and on test, you'd have graph paper. But so let's type this in. So it would be 2x squared plus 5x plus 3. And I'm going to just go, I could go to table, or hit graph, see where it is. All right, so I'm over, in this zone. So maybe I'll just change my window to get this area. Press window. So maybe like negative 5, negative 3 to 3 for the x's. And I could do the same for the y's, actually. Negative 3 to 3 would probably work. You know, I'm just ballparking it first, and then I'll fix it later. And that's pretty good. Look how that barely goes under. That barely goes under. So maybe I can find some other information. I can find some roots, maybe. So we'll see the root. Oh, one of the roots is a negative 1. So that's a root, negative 1. And I could find the other root, and I do know it's at negative half, 1.5. So it's right there. So those are my two roots. And I know it crosses up here at z is 0 is 3. So that's an important point. So this is my parabola. Now it's a equal, so that means it's solid. Dips down, and it goes, you know, that's a strange parabola, but it works. Works for this problem. It says show the roots and the turning point. Then you want the turning point. Okay, let's get the turning point. So we go to calc. So second trace, second calc. This is a minimum problem, so press 3 for minimum. And I'm going to do left bound, right bound, so I have to get on the left side. Enter, right side. Enter, back it up. And I know this turning point is at, I'm just going to round to like 2 decimal places, 1.25 and negative 0.125. I'll just keep that like that so you can see it. Oh, I guess I'm rounding to 3. All right. And then the last step is to shade this thing. So what I would do is I would check a point, like maybe 0, 0. That's a friendly point. It's over here. So I would say if 0, 0, if that's in the solution, I'd shade outside. But let's check. So I'm gonna plug in 0, 0. So 0, 0, 0, 3. Is 0 bigger than 3? And the answer is no. So don't shade there. This is a shade. It's a greater. It's going to shade like this. And don't forget labeling X and Y, all that good stuff. All right, let's try the next one. All right, question number 5. It's a cone. All right, and it's shaped. Now, I'll tell you this. This will not be on your midterm. But you should know how to do it. So it tells you the volume is 84. So I'm just going to go through it pretty quickly. You can slow it down and stop it if you need to. And it says the radius, the height is 6 more than a radius. So what I'm going to do is I'm going to let the radius equal x. So that means that the height is x plus 6. So it's going to be x squared times x plus 6. So I'm going to go through this one pretty quick for those that are interested. So to get rid of 3, I multiply by 3. And I got to divide by pi, or you can do this together. So I have to get rid of this stuff here first, these two things. So I divide that over, and I'm going to get 80.997 equals x squared times x plus 6. And what I'm going to do is I'm going to distribute. So I get 80.997. Keep all the decimals in your calculator. X cubed plus 6x squared. And I don't want to work with this, so I'm going to set this to 0. Minus 80.997 over equals 0. This I can't factor it, so it's a calculator question. I graphed it, and the graph looks something like this. This is my answer right here. I did calc intersect, and it worked out to be like x is 2.9994 something. So x is about 3 in this problem. And I actually plugged it in, I checked it. So if x is 3, that means the radius is 3, and the radius is 3. Therefore, the height is 9. Number 6 says find the value of k. And we did one of these in class. So this was what's given. 3x cubed plus kx squared minus 2x plus 1, all divided by x minus 1. Now in class we did it one way, right? You do a synthetic division. So 3k negative 2 and a 1. And it said they want the remainder to be 0. So that has to be 0. And then what we did was we kind of like worked backwards a little bit. We said, look, if this is 0, that means this had to be a negative 1 here to make the 1 go away. Well, then what would be here to make 1 times what? Negative 1. Well, that had to be negative 1. And then you work your way through it. Negative 2, what goes here to make negative 2 turn into a negative 1? Well, this has to be positive 1. Right? We just kind of go backwards like this. So this has to be 1. So 1 times 1 is 1. And this, I don't know, because I'm going to go the other way. So, sorry about the sound. So now we just go forward. So 1 times, bring down to 3. 1 times this is 3. And then we said, well, what would make the 3 turn into a 1? Well, that means this had to be a negative 2 to start with. So k is negative 2. Now, what if you're like, I have no idea what you're doing. So there's another way to do it. We could do the remainder theorem. Now, the remainder theorem says this. If you plug in the root, right, and whatever the answer is, whatever this evaluates as, that's the remainder. So I'm plugging in 1 because that's the root. And this is actually probably a better way, actually. And I'm forcing it to equal a 0. So now I'm just going to multiply it out here. So I got 3 plus k minus 2 plus 1 has to be 0. Clean this up, and you're going to solve it. So k plus 2 equals 0. Therefore, k is negative 2. I kind of like this way better, but whatever you wish. Let's try the next one. So number 7 says, use the remainder theorem, which we just used, to figure out what the remainder is when you divide by 2, so x plus 2. So my root would be x equals negative 2. So that's what I'm going to plug in. So it'll be 2 times negative 2 cubed plus 3 times negative 2 squared minus 2 times negative 2 plus 1, right? I apologize. The original was 2x cubed plus 3x squared minus 2x plus 1, all divided by x plus 2. All right, so it said use the remainder theorem. Crunch this out. The answer is 1. If you did this by synthetic division, you get the same answer. Question number 8. Exactly the same question as number 8. They want, man, a lot of same questions. They want you to do this by synthetic division. All right, easy. We like synthetic division. -2, 2, 3, -2, and a 1. Remember, bring down the 2. -2 and 2 is -4. -1, +2, 0, 0, 1. The back spot is the remainder. Good. Number 9. List all the possible rational roots. We're not going to determine the answers here. We're just going to list out the roots. So it says the function is called p of x equals x cubed minus 2x squared plus 9x plus 3. These turned out to be like really weird, like only one good number and there's a couple of irrational. So I just want, we just do this. That is not the question for this problem. So that's actually the next question. That's question number 10. So let's put number 9 up here. Number 9, let's solve the roots. So p of x equals 2x to the 4 minus x cubed minus 6x plus 3. Factors of the back over factors of the front. Factors of the back. So let's factor the back. So we got plus minus 1 plus minus 3 over the front, plus minus 1 plus minus 2. So everything divided by 1, so it's plus minus 1 plus minus 3. And then we do the halves. Plus minus 1 half, plus minus 3 halves. Number 10. This is Descartes' rule of signs. So we're going to do the positive side first. We just look at the signs. So it's positive, negative, positive, positive. Count the sign changes. So there's 1 sign change, 2. So there's 2 or subtract off the conjugate pairs. So 2 or 0. Positive roots. Negative roots. We do odd powers change signs, evens keep. So negative, right, becomes negative. A cube becomes negative. The square stays. The x to the first changes. The regular number stays. There's only one change. So this has one negative root. So there's 2 or 0 positives. And there's only one negative. Try another one. So number 11. Cross that one out. Number 12. Given the polynomial. So it says p of x equals x cubed plus 7x squared minus x minus 7. They want us to do like pretty much like everything that we could do with this thing here. So first off, they want the possible roots. All right, so the possible roots. Factors of the back over the factors of the front. So it'll be plus minus 1 plus minus 7 over plus minus 1. Therefore, it's just plus minus 1 plus minus 7. 2. Find the roots. Now, I gave you a graph. Right? And they want us to find the roots algebraically. So the roots algebraically. So that means synthetic or factoring. But I would do the graph first. Look at your picture. Punch it in. If you didn't do so, here's your window. It's 50s. Up at the top. Negative 10 down here. And this is pretty tight. I mean, you know, it's like 3, let's say 10, 10, I guess. So that's going to be my window. And I know this because I already did it. But, you know, you could look at your table and mess around with this. So I'll punch it in. So. And while I'm here, I'm going to type in the second equation equals 0 so I can find the roots. And I already said the window, so the negative 10 to 10. Let's type in what I say. And negative 10 to like 50. Oy, oy, oy. Hit graph. All right. Now, I know that there's negative 7 back here. That negative 7 is my y-intercept. So I really know it crosses down here at negative 7. And if I do calc intersect, second calc intersect, enter, enter, you get the root. This root here is at 1. All right, so I know it's at 1. There's a root at 1. But I got to show it's at 1. And if I do the same, I can go back here also. I know it's going to be here at negative 1. And I know it's going to be at negative 7. These are my roots. It goes pretty high. We'll find the exact thing. It tells us to do it later. But it looks something like this. Ballpark. So let's do this roots algebraically. Now, I know it's at 1. So I'm just going to pretend I didn't know. And I'm going to do synthetic division. And I'm just going to show it's at 1. There's nothing wrong with knowing the answer before you start. Just don't cheat. So 1, that's 8, 8, 7, 7, 0. So if that's the remainder of 0, that means 1 was a root. Now, what I'm going to do is I'm going to take this, even though 7's a little weird looking. This is my new equation. Now, you could just keep doing synthetic division, but I know it's right here. I can factor it. It's easy. So it's actually probably might be a little quicker. These are my roots. So I say find the roots. 1, negative 1, negative 7. Those are my roots. Next part, determine the number of possible positives and negative roots. So they want Descartes. So first off, so for the positives, we just look at, right, we keep the signs of the original. So it's positive, positive, negative, negative. 1 sign change. So there's only 1. Notice there's only 1. That works out. It's exactly 1. Now we do the negatives. We flip the odd powers. So it'll be negative, positive, negative turns to positive. Keep the regular number. So this is 1, 2. So it's 2 negatives, but they could have been imaginary. So it's 2 or 0. These are the possible roots. What else do they got here? They have relative mins and maxes and stuff like that. So why don't we do the max and min? That's from the calculator. So we're going to do second calc, and we'll start with the max. So number 4. Actually, I should start with the minimum. Second calc, we'll do the minimum since I'm down there. Number 3. Left bound, so get on the left side of the minimum. Then get on the right side of the minimum. And back it up, hit enter. So the minimum occurs at 0.07, comma, negative 7.0. Let's go to two places. 4. So that's the min. Second calc max, number 4. So now we gotta get all the way to the other side. And the max is negative 4.74 and 48.52. And finally, the last thing was there was a number line that we were supposed to complete, f of x. And this is really the roots. So you can put the roots on here. So you find the roots first. And what you want to know is if it's above or below the x-axis. So what I would do is I would go to table set and turn it on to ask. And what I'm going to do is I'm going to plug in values into the calculator. So like over here I want like negative 8. So I'm just going to type in negative 8. And the answer is negative 63. So it's a negative sign. Now what that means is it's below the x-axis. So that's why it's below on this. On -8 would be below. To the left of -7, it's below. And so if you didn't have a graphing calculator, you would do this first to help you graph without a calculator. So let's pick -2. That's a positive 15. Positive means it's above. So in between -7, -1, it should be above, just like we said. Maybe a 0. That's a nice one. That's our y-intercept. That's negative. And finally, something like positive 2. It's that positive. And we know it's above. And we already graphed it, so that's good. Looks a little messy, but that's a nice question. All right. That was it, guys. Enjoy the rest of your snow day. Thanks.